So in this video, we're going to look at using the Pythagorean identities again. And so we're going to try to solve the following. So solve in the interval 0 to 2 pi. So this first one we're going to do here is secant x plus 1 equals tangent x. So if I look at this problem, I have secants and I have tangents. However, I'm not able yet to use the Pythagorean identity because I don't have anything squared. So somehow I want to get a squared into there. That way I can kind of either change everything to secants or change everything to tangents, whichever works better. So the first thing that I am going to do in this case is I'm actually going to square both sides. So we're going to have secant x plus 1 squared equals tangent squared x. And if I square out secant squared plus x, that actually is secant squared x plus 2 secant x's plus 1 being equal to the tangent squared x. And now I can use that Pythagorean identity that says the tangent squared x plus 1 equals secant squared x. So tangent squared x is going to be secant squared x minus 1. So we have secant squared x plus 2 secant x plus 1 equals secant squared x minus 1. And so in this case, if I subtract the secant squareds to bring them to the other side, so subtract the secant squared x from both sides, you'll notice that my secant squared x's go away. So I'm left with 2 secant x plus 1 equals minus 1. So now I could just solve for secant x. So I'm going to subtract 1 from both sides. So I have 2 secant x equals minus 2. Divide everything by 2. So we have secant x equals minus 1. And so we're looking for where the secant is equal to minus 1. Remember, the secant is the cosine flipped over. So we're really looking for where the cosine of x is equal to minus 1. And that happens to occur at pi. Now, the issue is that I squared both sides of my equation. And if you recall, anytime you square both sides of your equation, sometimes you might get answers that are extraneous roots that don't work. So we actually also have to check our answers in these problems. So we're going to check them back in the original. So we're going to look at the secant of pi plus 1. And we want to know, is that actually equal to the tangent of pi? And so if I check that out, the secant of pi is negative 1. So it's negative 1 plus 1. Is that actually equal to the tangent of pi? And the tangent of pi is 0 divided by negative 1. So is 0 equal to 0? Yes, it actually is. So in this case, we do have that one answer, x equals pi. Okay, so let's try another one. I think let me see. Yeah, I thought I saved that. Okay, perfect. Got our unit circle. So B, I have the square root of 1 minus cosine x equals sine x. So again, here's one where I have a sine, I have a cosine. The cosine is trapped underneath the square root sign. So I'm actually going to square both sides to get that square root to go away. Equals sine squared x. So we're left with 1 minus cosine x being equal to sine squared x. So I can use that Pythagorean identity, right? That sine squared x plus cosine squared x equals 1 to replace the sine squared x. So 1 minus cosine x is equal to 1 minus cosine squared x. And if I move everything over to the left-hand side, I'm going to end up with cosine squared x minus 1 plus 1 minus cosine x equals 0, or cosine squared x minus cosine x equals 0. In this case, I could factor a cosine out. So we're going to have cosine x times cosine x minus 1. A lot of people get confused with this minus 1. So remember, if you're taking the entire thing out, you have to leave a placeholder. So you have to leave a 1. The other thing is you can always double check if I were to redistribute this cosine x. So cosine times cosine x gives me cosine squared. And then I need cosine times something. So that something's going to be a minus 1 to get that minus cosine. And now I can set each piece equal to 0. So cosine x equals 0. Cosine x minus 1 equals 0. So the cosine is equal to 0 when x is equal to pi over 2 or 3 pi over 2. Over here we have the cosine of x being equal to 1. That happens when x is equal to 0. So I have 3 potentials solutions, but I have to check them all. So we're going to check, so we'll start with checking x equals pi over 2. So if I check x equals pi over 2, we're looking at the square root of 1 minus the cosine of pi over 2, and I want to know is that equal to the sine of pi over 2. So the cosine of pi over 2 is 0, so is 1 minus 0, is that equal to the sine of pi over 2 is 1. So yes, that actually does work out. So the next one we'll check will be that 3 pi over 2. So we're looking at the square root of 1 minus the cosine of 3 pi over 2. And is that actually equal to the sine of 3 pi over 2? So this is going to be the square root of 1 minus the cosine of 3 pi over 2 is 0. Is that going to end up being equal to negative 1? So is the square root of 1 equal to negative 1? No, because this is a positive 1, this is a negative 1, so they're not equal. So 3 pi over 2 does not work as an answer. And then finally, x equals 0. So is the square root of 1 minus the cosine of 0, is that equal to the sine of 0? So square root of 1 minus 1, is that equal to 0? So square root of 0 equal to 0? Yes. So we only have 2 answers this time. Our answers are x equals pi over 2 and 0. So just remember, if you square both sides, you do actually have to check your answer afterwards.